MS Ramaya University of Applied Sciences.
Hi students, let us discuss ASK scheme. The aim of the experiment is study of pulse shift scheme. Amplitude shift keying ASK is a form of amplitude modulation that represents digital data as variations in the amplitude of a carrier wave. In an ASK system, the binary symbol 1 is represented by transmitting a fixed amplitude carrier wave and fixed frequency for a bit duration of t seconds. ASK uses a finite number of amplitudes, each assigned a unique pattern of binary digits. Usually, each amplitude encodes an equal number of bits. Each pattern of bits forms the symbol that is represented by the particular amplitude. The demodulator, which is designed specifically for the symbol set used by the modulator, determines the amplitude of the received signal and maps it back to the symbol it represents, thus recovering the original data. Frequency and phase of carrier are kept constant. The apparatus required are Syntec 2156 and 2157 kit with power cords, digital oscilloscope, probes and connecting cords. The connection diagram is as shown. The procedure is connect the power supplies of Syntec 2156 and Syntec 2157 but do not turn on the power supplies until connections are made for this experiment. Make the connections as shown in figure 9.1. Switch on the power. On Syntec 2156, connect oscilloscope channel 1 to clock in and channel 2 to data in and observe the waveforms. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of modulator circuit on Syntec 2156 and observe the waveforms. Vary the gain potentiometer of modulator circuit 1 on Syntec 2156 to adjust the amplitude of ASK waveform. On Syntec 2156, connect oscilloscope channel 1 to NRZ and channel 2 to output of comparator on Syntec 2157 and observe the waveforms. Figure 9.2 shows ASK modulation waveforms. Figure 9.3 shows ASK demodulation waveforms.
Hi students, current experiment is amplitude shift keying, modulation and demodulation. Apparatus required are Syntec board 2156 and Syntec 2157. In Syntec 2156, we had line coding schemes. We take one of the line coding schemes and feed it to the carrier modulation. Here in carrier modulation, there are two inputs. The signal input will be the output of the line coding scheme, and the carrier input is fed from these carrier signals. I take the 960 kHz sine wave as the carrier signal, and the output of this would be the amplitude shift keying modulation scheme output. And demodulation scheme will be in the Syntec 2157 scheme. Here ASK demodulator, the output of the carrier modulators will be fed into the input of a ASK demodulation. Here it acts like a half wave rectifier, and the half wave rectifier output will be fed into the low pass filter, and then low pass filter output will be fed into the comparator. Comparator output will be the same as the data inputted from the line coding scheme. And the digital oscilloscope, this is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs, and these are the horizontal position adjusting knobs, and this is the time scale adjusting knob. These are the connecting probes for digital oscilloscope, and these are the connecting wires for the Syntec 2151 board. Now let us start the connection for the amplitude shift keying, modulation and demodulation experiment. Take the connecting wire, connect the clock output to the clock input and connect the data out to the data in and connect the any one of the coding scheme. Let's take NRZL and to the signal input and take the carrier from the modulation 960 kilohertz to the carrier input. Connect the carrier modulator output to the input of ASK demodulator. Since I am using the two boards, I have to make the ground common. I am connecting the ground of the Syntec 2156 to the ground of 2157. Output of ASK demodulator is connected to the low pass input of the low pass filter, and then output of the low pass filter is connected to the input of the comparator. This completes the connection. Now let us connect the probes of channel 1 and 2 for the oscilloscope. Probe 1 is connected to the NRZL and negative is connected to the ground, and channel 2 is connected to the output of the carrier demodulator and to the ground. Negative is connected to the ground. Now let us switch on the power supply of both the boards as well as the digital oscilloscope. Now press the auto set button and let us press the run and stop one. Here you can see this is the data streams and this is the amplitude shift keying modulated signal. Whenever the input signal, digital signal is high, at the time we are transmitting a sine wave of certain frequency, and when there is a signal is low, we are not transmitting any sine wave. So this is the amplitude shift keying modulated signal. Now I am removing the probe from here and connecting to the amplitude shift keying demodulator output, and this to the negative to the ground. Then again press the run and stop button and again do it. Here you can see the half wave rectifier output. Earlier I used to see the full sine waveform. Now I could able to see only the positive half cycles of the sine waveform. This is half wave rectifier output. Once the half wave rectifier output is passed through the low pass filter, I will show the output of the low pass filter. Let us change the channel 2 CRO probe to the output of the low pass filter. Here again you press the run and stop. You can see wherever the amplitude is high in the digital waveform, there here low pass filter output is also high. Whenever it is low, here also it is low. If I pass the output of the low pass filter output to a comparator, then I will get a perfect digital waveform with 0 and 1, means with low and high voltage. Now I am showing the output of a comparator. Now I am removing here from the low pass filter and connecting to the comparator output, and to the ground. Again you press the run and stop button, and again we will press the auto set such that the magnitude will be set to the normal, and then again you press the run and stop button. Now you can see the transmitted digital data is modulated through the amplitude shift keying and demodulated, and now we are getting the same stream of data which is transmitted and as well as the received data. This is what the amplitude shift keying, modulation and demodulation.
At MSR, you mark your imagination other.